This talk is arranged by the Video1 Center for Bad Research on Ecosystem Sustainability, so which is located in the Kannur. So, on behalf of our department and Video1 Cyprus, so I welcome Joseph, and so I am very happy to introduce his academic credentials. So he did BSc Zoology in University of Calicut, and he did MSc in University of Mysore, and he finished a PhD in the same institute, that is the University of Mysore. So after that, he moved to the Israel for doing the postdoctoral research, and now he is working as an assistant professor in Kannur University. He is a well-known person in the animal behavior, particularly the remote sensing. He has published more than 20 or 25 papers in well-reputed peer-reviewed journals. He also being as a reviewer in many journals like remote sensing, scientific reports, forest, and environmental science. It is very if you want to be if you are in researchers, so being a reviewer or being an editorial committee member is a very credible one. Right? So he is being more than 12 journals reviewers, and he published, he participated in many conferences, and he went to the, he has delivered many lectures in the various institutes. With this short info, I would like call the James for delivering a lecture on the remote sensing oriented. So he is well-known person in the animal behavior.
Okay. Shall I turn on the presentation? Can you see my screen now?
Yes.
Okay, so shall I start? Okay. Thank you, Pastor, for such a wonderful introduction. And I thank the organizing committee of this seminar, Pavel Sibrus, and especially Dr. Pastor for inviting me to such an auspicious gathering. So today I will be talking on the topic called as satellites, wildlife and diseases. So mainly I will be talking on how we can use satellite remote sensing for wildlife and disease research. So as all of you might already know, the major causes of habitat loss of many species around the world are deforestation and global climate change. And as you can see in this picture, as marked in the red, you can see that a lot of forests around the world are drastically declining. And this decline of forests have led to habitat loss of many species around the world. And as you know, we are now in an era called as Anthropocene. We have renamed the era from Holocene to Anthropocene. And in Anthropocene, we have to regularly monitor and assess our forests because a lot of forests around the world are drastically declining. Often, field methods are used to assess and monitor forests around the world, but there are several limitations to these field methods, especially the field methods are often more time consuming, it requires huge manpower, and the area of extents that needs to be covered and the terrains, especially in tropical rainforests, make it very difficult for field methods to be used in tropical rainforests. Remote sensing offers solution for this, as remote sensing using satellites can cover large extents of area of Earth, and we can monitor large extents of area of Earth using remote sensing, and it's less time consuming and it requires less manpower as So basically, in today's talk, I'll be talking about some of the applications of remote sensing, what we have used for conducting wildlife research. And I'm going to start with mapping of different vegetation types with high accuracy for species conservation in South Asia. And during 2015 period, we started a project for mapping the different habitats of primates in South India. And when we started this project, what we observed was that there was no proper accurate maps of vegetation types for mapping the habitats of primates in South India. So what we decided was that we will use remote sensing techniques to develop proper accurate vegetation type maps of South India. We need to develop proper vegetation type maps because different species would have different land use associations and different vegetation associations. So some species would be associated with coffee plantations, some species would be associated with forests, some species would be associated with tea plantations. And to properly understand different land use associations of species, we need to have a proper understanding of the different vegetation types in different habitats. But even in remote sensing, we encountered several problems. So one of the major problems was the percentage of cloud cover in different images. As you know, the major data used for remote sensing is optical data, which means that the satellite takes photos of a part of the Earth from the space, and we use those photos for the classification of the images or the classification of different vegetation types. So the percentage of cloud cover is a big issue in remote sensing, in remotely sensed images. So this is also what we saw. And as you can see here, the percentage of cloud cover was really high between March and November in 2016 and 2017. So this data, what is being shown here is from December 2015 to November 2017. And as you can see, there were only 2 months of data which were cloud free. So we decided to take the optical data from these 2 months. And we also decided to use the combination of the optically remote sense data with that of the synthetic aperture radar data. So one of the advantages of synthetic aperture data is that synthetic aperture data is not affected by cloud. So it is taken using something called as active remote sensing. So the satellite itself sends a signal to the Earth and it takes back the signal. So we use the data from 2 different satellites as I previously mentioned. So one of them is Sentinel-2 satellites. So as you can see here, this is the data from the Sentinel-2 satellite. And we also used the data from the SAR satellite, which is a synthetic aperture radar satellite, and this is the data which you see here. And we combined both of them and we developed a technique by experimenting a lot of different methods of classification. And we developed a technique which could accurately classify different vegetation types in the Western Ghats. And these were the different land use types we classified using these images. So as you can see that there are a lot of different vegetation types covered here. And we could produce maps with high accuracy, which was more than 80% accurate. And this was the final method that we developed. So we had Sentinel-2 bands 8432. We have the NTBA of these Sentinel-2 satellites, and we have used mean texture of band 8 and band 4. And we had the bands of Sentinel-1 and also their entropies, which were the texture bands. So we developed a new technique for mapping the different vegetation types in the Western Ghats. And we also extrapolated our data to the whole of the southern Western Ghats, and we could produce maps